Okay, this is class 4, and we're continuing on. So I had this example right here. This is a gear train example. This is problem 1316 out of Shigley, and we have a double reduction gear set shown in the figure right here. So here's what the original figure looks like. Is driven through shaft A right here. So this shaft right in there, and at a speed of 700 RPM. And what they did in the figure here, here's the front on view, and in order to see it from the side, they decided to rotate this guy down and move him over there. So that's what that means by way of showing it here. Gears 2 and 3 have a diametral pitch of 12 teeth per inch and a pressure angle of 20 degrees. The second pair of gears in the train, gears 4 and 5, have a diametral pitch of 8 teeth per inch. And that's totally fine. They don't necessarily have to be the same pitch. But the gears that mate each other do need to have the same pitch. So that's also a factor sometimes that we could put inside when trying to get a design that has criteria that's forcing us to try to have certain dimensions or ratios and that kind of thing. Have 8 teeth per inch and 20 degree pressure angle. The tooth numbers are 12 right here. So there's 12 teeth right here. Is driving 3, which is 48. So there's 48. 16 right here is driving 36. So we want to find the speed and direction of shaft C, which is this shaft right here, this output shaft. I don't know if I click on this, if this is going to give me the same thing. I thought that on this gear generator, if we went to this, no, it didn't do it. I wonder if I go to this, click out, let's see, and paste it in. Let me see what happens if I paste it in. There you go. Okay, so this is like the arrangement, or kind of the arrangement, I think, of the thing. I even made a 7 right here for the input because there was 700. Because I don't think it actually gives us any of the tells us what the output is going to be here. There's no mathy thing that shows us. But there you go. There's the so it's got a pitch of 12, and you can see that it's got how many teeth on this one? Let's see, this is the driver right here. This is the driver right here. Oh, they're actually telling you what the RPM is right there. Okay, there it is. Okay, right there's the different ratios. Sure. So here's the ratio of RPM of 7. So instead of 700, 7. And it tells, and we have gear teeth of 12. Is that right there? Is it the same as the problem? Problem said we had 12, 48, 16, and 36. So we have 12, 48 right here, and I think we have the right pitch right there, right? It gives a 12 pitch, and then this one has an 8 pitch. So there's the arrangement right there. It's kind of interesting, right, to see the thing. And we're predicting probably an RPM output of 78 right here, I think. So that's the output that we can predict from using this clever little tool here. So I also extended the problem down here to ask a what if we wanted the input and output to have the same distance, right? We want them, the shafts, to align. So I have NA is 700 RPM. I think they said counterclockwise, right? And they say, well, here we see that it's counterclockwise, at least from this direction. If you flip it and look at it from the other direction, it's going clockwise. N2 was equal to 12 teeth. Therefore, the diameter is going to be N2 divided by P, or 12 divided by 8, right? Because this session has, wait a minute, did I do that wrong? Do they all have a pitch? No, no, no. Oh, I messed up on here. Okay, by the way. That should be by 12, right? Because they have a diametral pitch of 12. So I have something wrong on here. Make sure I fix that. N3, 8. Right, so I don't know why I was doing there. And 3p. That's 48 divided by 8. So I just said 8. It's supposed to be 12. Not listening. I could do that. That's 1 inch. Okay. And this right here, 48 divided by 12. I'm just about to divide it. Right? Okay, 4. Great. It says 4 inches. The D4, let's see, this is supposed to be 16 divided by 8 is 2 inches. And this is 36 divided by 8 is, and I think that was the 4.5. Let me double check. 4.5 inches. I don't think actually we even needed any of that, so I'm not sure why we put it in there. Because we wanted to find the speed and direction of shaft C right there. All we need to do is find what the gear ratio is going to be. And so that's going to be 2 is driving 3. Right, and 4 is driving 5. So, and so there's 2 stages, and each stage reverses. So the input is going to end up equaling at the output. So you're going to have 12 and 16, and that's going to be driving 48 and 36. And so you have a 0.1111 ratio going on here. So NC of an output is going to be N equal to N5 of an output, which is going to be E times the input. So 0.71111 times our 700 gives us 77.8 RPM. Counterclockwise is the answer. So you see that actually matches up with what we found right here, right? 0.78 is the output. Right? I think this up here, maybe I should have continued onto the thing. I think maybe I continue this on in another example problem. Well, let's see. Let's see what happens. What gear combination would be required so the input and the output shafts are concentric, right? So that they have the input matches the output onto the thing. So input had to align with if the input had to align with the output, what we need to have is N2 plus N3 right there, right? This distance right here, so would have to be equal to N4 plus N5. But it's actually right here, it would be that divided by P in the 2 to 3 divided by P from the 4 to 5. And I don't know if I did that in the in my example right here. So say let's say also, what if the same pitch? Okay, so now we can get rid of them, but in the original problem here we were using a different pitch. So so if we're using the same pitch right here, we could, and trying to find some combination right here, we could say first off, let's have the same pitch, right? Let's say a what if we had the same pitch, and try all the same things. So we could try. I don't know if this is an example I want to do anymore. Anyway, so if these are the same pitch, then those teeth have to equal each other. So let's say N2, we had 48 teeth, right? This is what from the original problem right here. So we went to 48 teeth, 16 right here is going to be, with our 16 and our 36, we would find that N2 would have to be equal to 4. That's no good. So let's try if we had this the same. We had 12 coming in, and we don't know what this is going to be, right? And what we would have now is N3 would be equal to 40. See, now let's try it out. Let's say that what's the gear train ratio? Well, that's going to be 12, 16, and then 40 and 36, and you end up with 0.1333, and that's 20% faster. Is that going to be good enough? I mean, you're competing with these things. Like, maybe that's going to be acceptable for it, but probably not. Whoever's determining what this gear ratio is, they have something in mind, and it's 20% is probably too much. We could also try to change the other stage gears, right? So let's use the original first stage here, and let's change what this last one is going to be, right? So what N5 is, right? And so in order to get these to line up, once again, we're making this assumption right here. That's another variable we could get to get this thing to match up. We would find that we had 44, right? And so our gear train ratio is like 12, 16, 48, and 44 now, 0.09091, and that's 18% slower. So these are just like considerations as we're trying to mess around with the thing. We could start coming up with formulae but I think it's probably this is a conceptual, like something that you would, not conceptual, but just for demonstration, that you know, someone might create a criteria that's kind of difficult to achieve. So you might want to try some various things. So if you combine this with that previous example, you can kind of have an idea that there's certain problems that you could face in being an engineer. I mean, not just this gears thing where you have to kind of come up with a scheme to try to work around and try to figure out how you please everyone. You might be able to find some guidance somewhere that says, well, just use this procedure and you're going to be able to get for when you have certain criteria. But I found that there's more of this kind of thing necessary. I don't know if I like this example anymore, but we'll keep it. It's here. Let's keep it.